That year was a tragedy. That never, ever should have happened. We lost a lot of amazing, beloved people. Those individuals sacrificed their lives helping others. By the time the world knew what was going on, it was way too late.
I personally diagnosed the first case of Ebola that came into Sierra Leone.
I lost my boss, Dr. Shekumar Khan.
Colleagues in the hospital, we are dying every day.
We lost all those people. They were so close to me. So many nurses in the hospital, the lab, you name it.
People in the community, they were like running away from us.
My family called me, Simbigi, I know you are fighting to save life in this country, but we need you more. So please come back.
I'm alive today. I'm glad to see that.
Sequencing the genome of a virus is very impactful when you're trying to respond to an outbreak because everything about that virus is sort of based on that sequence. So we are really invested in getting sequencing on ground in every country. The more you empower all the way to the point of infection, the better.
Why are there so many new deadly infectious diseases like Ebola, Zika, chikungunya, and avian flu?
We're here at the Broad Institute to talk to Pardis Sabeti, who's using genomic technologies to study viral outbreaks. Where do these viruses come from?
We think about these, what we call emerging diseases, as these things that are new in the human population, suddenly coming out of nowhere. And what I started to realize as I studied these viruses is they're already here.
The viruses are so small and so difficult to detect. How do you sequence them?
That's the amazing thing about the technological revolution that's happening in genomics is it's getting more and more powerful, more and more sensitive. We're looking for all the reads and everything that's in your blood in another clinical specimen and find those reads.
When a patient comes into the hospital with a suspected fever of some sort, their samples are taken and brought to the clinic. We take that sample and then isolate the RNA that we want. We then have to make the RNA sample into cDNA, which is just a complementary DNA of the RNA, and that's what's required for sequencing. After we make cDNA, we take the sample and we make sequencing libraries, and those libraries are short fragments of the genetic material that will then be put onto the sequencing machine to get the data and sequencing information.
We can use that information to help us develop diagnostics and vaccines and therapies, because fundamentally they're all based on the genome sequence. We can take sequences from a number of different viruses in different patients, and we can create a family tree. And one of the things we found in the Ebola outbreak was that the virus likely entered the human population once, and then from there was transmitting from human to human. The likely first case happened in December of 2013 in a village in Guinea. A small child succumbed to the disease, but there's no diagnosis in place. It took all the way until March of 2014 when we first recognized that the virus was in Guinea. And then it spilled over into Liberia. By the time it came into Sierra Leone in May of 2014, it was like a tidal wave, and it was way too late.
Having two of my predecessors succumb into such deadly disease, and here am I working in the same unit. I see it as an opportunity for me to break the cycle. We have such a great opportunity, a wonderful one, to collaborate with partners in the United States. It's a wonderful thing to have them as partners, and we work, I would say, as brothers and sisters. We are all one, working together with the one aim in us understanding the disease and better improve diagnosis, treatment, and further management.
Our biggest focus was how to get attention to what we thought was an escalating crisis that was not really getting attention.
When you sequenced the Ebola genome, what was the first thing you did?
We released it to the web. We immediately got lots of people reaching out to us, developing diagnostics, thinking about vaccines, analyzing the data.
When I got to West Africa to bring the sequencing technology and to train the technicians and staff on how to use the sequencing technology, it was a really humbling experience. The struggles that they go through day to day in their own labs with power, with dealing with the heat, dealing with limited resources. A lot of the sequencing reagents and enzymes and things that we use day to day in the lab are not available. So if you run out of something, you can't just call up a vendor and have it delivered the next day.
We have a program bringing them here to the US, working with us in our lab. We're now at 76 individuals that we've trained in this program from 6 different countries. They're all on the front lines, and we continue to engage them so that they can share best practices.
The training expertise we have from abroad, and I think we're using it now to help our countries. At least with now we're more prepared. The training was all about genomics, and the thing that took me to the abroad was DNA, was sequencing, and since I came back, I've been doing it efficiently. We're having good quality scores, good cluster densities. So it's like we're rocking it here.
With all the sacrifices that people have made, how can we apply those lessons?
Lessons learned here is that, working together as a team helps us to achieve greater progress. And for us here, having diagnostic capability on site helps us a lot, especially having a sequencing machine on ground. It helps us to track down outbreak and also be in position to diagnose almost all patients that will come with unknown causes of illness, especially those with fever.